In this video, we'll look at question 27 from the 2016 exam. So in this question here, we have a transverse wave propagating through a medium with frequency 5 Hz, wavelength 4 centimeters, and amplitude 3 centimeters. Our task is to find the distance traveled by a particle in this medium through which the transverse wave propagates in 1 minute. So here we have a wave at a certain time. Can you draw this wave just a bit, say just a millisecond after this moment of time? It will look something like the blue wave, assuming that the direction of travel is to the right. So let's see what happened to one point on this wave in the median, say this one here. So at the time the blue wave is shown, it is now at this position here. And even later, as we can see on the dark green wave, it will go up again by a bit. It's now here. And just like this, it would complete a full oscillation. In other words, every point in the medium through which the wave propagates, even though the wave is transverse, it goes in this direction, the particles itself oscillate perpendicular to this direction, up and down, where half the distance here is amplitude A, so from a baseline 0 here to the extreme point. So in one oscillation, this point travels by 4A. It goes up, 1A, then down, 1A, down, and back again, 4A in total, which in our case is 4 times 3 equals 12 centimeters. So to answer the original question, we now need to know how many oscillations occurred during this time of 1 minute. Fortunately, we have the frequency, and the period of the oscillations will be 1 over the frequency. So the time which it takes to complete one oscillation is 0.2 seconds, 1 over 5 Hz. And the total number of oscillations completed during 1 minute is 60 seconds, that's 1 minute, divided by the time it takes for one oscillation to be completed, which is 300 oscillations in 1 minute. So we have 300 oscillations. During one such oscillation, we know that a particle will travel 12 centimeters in the medium, up and down and back up. So the total distance traveled by that point will be 12 centimeters times 300, which gives 3,600 centimeters. And that is our final answer, and in the exam, that was option E.